Hi friends, in this video let us solve the simplest related question asked in GATE 2008 EC paper. The question is, the signal x of t is described by x of t is equal to 1 for t varies from -1 to +1 and 0 otherwise. Choose the angular frequency at which Fourier transform becomes 0. Right, that is a simple question. Let us see how we are going to see. So first we have to find Fourier transform, then find for what value of omega it will become 0. Right, so they are given x of t is equal to 1 for -1 to +1, 0 LC. Right, so what we are going to do, we know Fourier transform x of omega is given by minus infinity to plus infinity x of t equal minus j omega t dt. Right, so what we are going to do, x of omega, x of t varies from -1 to +1, there only it has value, so -1 to +1 x of t is 1 equal minus j omega t dt. Right, so integrate equal minus j omega by minus j omega -1 to +1, 1 minus j omega, take it outside, so it will be equal minus j omega minus equal j omega. If you simplify, what you get is, so it will be 2 sine omega by omega. Unless you take this one minus outside, so 1 by j omega equals j omega minus equal minus j omega. Equal minus j omega into minus j omega by j is 2 sine omega by omega. So this is x of omega. When this will become 0, when omega becomes 0, pi, it will become 0. When omega 0, you cannot put 0. When you put omega 0, it will be 0, 0, 0 by 0. So that is not the answer. So when you put omega is equal to pi, x of omega will become 0. When you put omega is equal to 2 pi, x of omega will become 0. So for omega is equal to pi and 2 pi, x of omega is 0. For 0, numerator will be 0, at the same time denominator will also be 0. That is not the answer. So the answer is pi and 2 pi. Option A is the right answer. Thank you.